let's spend a little bit more time talking about writing equations for sine and cosine based on either transformations or key features, because this can be a pretty tricky topic. So remember, there's several different features or transformations that we can identify here. So the a value, right, whether this is sine or cosine, tells us the amplitude of the graph. And another way to think of the amplitude is that it is going to be equal to half the distance between the maximum of the graph and the minimum of the graph. So remember, it's not the total distance from the maximum to the minimum, but it's half the distance, or the distance from the midline to either the maximum or the minimum. We can have a horizontal shift, right, or a vertical shift, depending on whether we're talking about a C or a D value. This is a vertical shift, and remember that D value also tells us the midline. That vertical shift tells us the position of the midline. And another way to think about the midline is that it is calculated as either the average or halfway point, however you want to think of it, the average or the halfway point of the maximum and the minimum. So the difference between that and the amplitude, right, is the midline is the actual halfway position. The amplitude is half the distance. And then one more value in here, this b value, can tell us about the frequency of the graph in 2 pi units. But just as it can tell us about the frequency, it can also tell us about the period of the graph if we do a little bit of extra calculation. So remember, the period is the length of one cycle, so we keep that definition in mind. And how the period relates to the b value here is we can calculate the period as 2 pi divided by b. So this is going to be, I hope, a helpful formula for us today as we look at some other examples of writing these equations here based on these features, and particularly how do we use the b value and the information about the period correctly. So let's do a couple of examples here. So example 1, it says write a transformation of sine that has a maximum of 8, a minimum at 2, and a period of pi with no vertical shift, or excuse me, no horizontal shift. So if I just think about maybe visualizing this a little bit, okay, so I've got some sort of sinusoidal graph, right? It has a maximum at 8 and a minimum at 2. So how does that help me? Well, if I think about the distance there, right, the distance between the maximum and the minimum is 6, right? And halfway between the maximum and the minimum, the average of the two, or halfway between them, would be 5. So that 5 is going to be our D value, and then that means that we must have an amplitude of 3 above and below that midline. So that gives us a little bit of information. We have an A value of 3. We have a D value of 5. It says that there's no horizontal shift, right? So we don't have to worry about any kind of C value, but it tells us that we have a period of pi. So I'm going to take that information, I'm going to work with it over here. So the period we just wrote up above is 2 pi over b. So if we know that the period is pi, then what we need to solve for is that b value, right? This is our unknown at this point. So a couple of algebraic strategies here. I think we should get b out of the denominator by multiplying both sides by b. So we reduce on the right-hand side and we get b pi is equal to 2 pi, and then to completely isolate b, oops, not divide by b, divide by pi. So we reduce on the left-hand side and we get b all alone. And on the right-hand side, we get some pi over pi, which reduces to 1. 2 times 1 is 2. So we have a b value of 2. So it looks like we've got all of our necessary information. A is 3, D is 5, and B is 2. So I'm going to write my equation as y equals 3 sine of 2 theta, or 2x, depending on your variable preference, plus 5. Now, the cool thing about writing an equation here based on these features is that I can always check it, right? I can check it using a graph, using a tool like Desmos. So if I just get this out of the way, I've got the equation that we just wrote, 3 sine of 2x plus 5. So if I look at that, it's got maximum values at 8 and minimum values at 2. So it certainly seems to fit that criteria. The midline of 5 means that we've got that starting point, right? That sine starting point right there where we want at a y value of 5. And then if we think about, the period of the function, we wanted the period to be pi. So that would mean that one cycle is a length of pi. And it looks like that's exactly, let me bring that midline there. Looks like that's exactly what we've got going on there. So the full cycle is pi units away, and another full cycle is another pi units away, and so on. So just something to think about there is that our b value, right, was not pi. Even though that was the information given in the example, we had to solve for the appropriate b value. Let's do another example. This one says write a transformation of sine that has been shifted left 1 unit, has a maximum at 17, a minimum at negative 11.2, and a period of 20. So we've got a little bit more going on here, some interesting things. So first of all, shifting left 1 unit, that's a horizontal shift. So we know that our C value is going to be negative 1, right? That's left 1 unit. But remember, in our formula or in our equation, we are going to see this written as like theta plus 1 because our transformations have that negative sign built right in. A maximum at 17 and a minimum at negative 11.2. So like example 1, we could draw a picture to give us a little bit of reference, but we're probably going to have to do some actual calculations to make this. My sine graph is a little bit pointy there. Let's see if I can do a better one. Oh, that looks just a little bit better. So we have a maximum at 17 and a minimum value at negative 11.2. So if I want to find the midline, or the D value, I'm going to want to find the average between the two, or halfway. So remember how you find an average is you add the two values together, noticing that even though we have a negative value, I'm still using addition between them, and we divide by 2. So in this case, adding that numerator, that would be 5.8 divided by 2 is 2.9. So we have a D value of 2.9, which again would be the location of our midline. We also need an amplitude. So we could do that a couple of different ways. We could think about, if this green line is 2.9, what's the distance above and below that? So we could use some simple subtraction that way. We could also find we could find the value, or the distance between negative 11.2 and 17 and divide that in half. However you choose to do that, you should get an A value of 14.1. So that would be the distance from the midline to either the maximum or the minimum. All right, so we have a a C value, a D value, an A value, and last we need is a B value. And we're going to use this information about the period of 20. So again, I'm just going to start by reminding myself of that formula. So the period is equal to 2 pi divided by B. So I'm substituting 20 as the period, and I have to solve for the B value. And so again, this algebraic process is going to look pretty similar because the formula we started with is pretty similar, right? So we're going to get 20B is equal to 2 pi. And then when I divide both sides by 20 to isolate B, I'm going to reduce that 2 over 20 to 1 over 10, or 1 pi over 10, which reduces further to pi over 10. Now, when I write my formula, I'm going to leave it in that fraction form. I'm not going to try to do a decimal approximation because we know that pi is an irrational number. And so anytime we try to approximate it, we're going to lose some accuracy. So I am going to write out my formula based on the information I've discovered. So 14.1 sine of, now this is where parentheses are going to be good friends of ours, I think, pi tenths times the quantity theta plus 1, right? That was our horizontal shift. Close the second set of parentheses, and then plus 2.9. I'm just going to double check that. Yep, that was our D value. So this formula is just a little bit more interesting than our last one. And again, this is where a tool like Desmos is just a really good tool to have in our back pocket, right? We can check that it fits those features. So I have my whole equation that we just wrote. Notice I'm using some parentheses, and Desmos makes this really easy to keep it in that fractional form. So I've got my maximum at 17, a minimum at negative 11.2, right? So all of those fit the criteria that I want. And let's see, if I think about the midline, we said was at 2.9, and it was shifted left 1 unit, right? That means our starting is at an x value of negative 1 instead of 0. So we've got that correct there. And then last thing, the period, it says is 20. So that means that one full cycle, so I'm going to start here. So this x value is 19. If I complete another cycle, I should be 20 units away. 19 plus 20 is 39, and I could continue, right? Every time I complete a cycle, I'm another 20 units away. So it looks like our equation is exactly what we want it to be. Just another couple of examples here based on graphs rather than descriptions, because I think making those connections graphically and verbally to those features is really important. So a couple of ways that we could approach this, right, is thinking about where the maximum or the minimum or the midline is. This particular graph, I think we have maximum values at 3.5 and minimum values at negative 1.5. So just like we did in the earlier examples, we could use that to actually calculate the midline. And even though I think we could visually identify the midline as y equals 1, I think verifying that with some calculations is just a good habit, because sometimes our eyes are not the most accurate mathematical tools, right? We can always use just a little bit of help. So when we simplify this, we get 2 over 2, which is 1. So we verified that that midline is at 1. Let's talk about the amplitude. If our midline is at 1, our amplitude here, the distance, looks to be 2.5. And again, we can calculate that. The difference between 1 and 3.5 is 2.5. So our A value is 2.5. Let's figure out what the period of this function is. Remember, the period is 1 cycle. So we could start it anywhere we want, like maximum to maximum. and it looks like that period is 2 pi. So if we think about knowing that the period is 2 pi over b, what would the b value have to be for this equation to be true? Well, then the b value would have to be 1, right? 2 pi divided by 1 is going to give us a period of 2 pi. And then any other shifts, a horizontal shift, it looks like we have been shifted to the left pi halves units. So left pi halves units would mean that our c value is negative pi halves. So putting this all together, we're going to get the formula y equals 2.5 sine of, now I could put 1 as my b value or exclude it completely because a b value of 1 won't change the values, theta plus pi halves, remember that opposite sign there, and then plus 1. So I think one more example together, and then you will be ready to give this a shot all on your own. So example 4, again, transformation of sine. So starting with maximum, minimum, and midline there, again, we could calculate the distance between -1 and -3, and we would get a midline or a d value at -2. Looks like our amplitude, our distance from the midline to either our maximum or minimum, is 1. It looks like there has been a horizontal shift. Now, I always look for the closest one, so I think in this case that would be left pi fourths units. You could also think about this as being shifted right 3 pi fourths units, as we could think of another starting point right here. You might get a slightly different equation than me or a classmate. Either way, as long as we're thinking about these as, appropriate directions and distances, I think we're going to be okay. I'm going to stick with left pi fourths, though, in this example. And then the last thing I need to do is I need to identify the period of the function. So I'm going to go from minimum to minimum here. And it looks like our period goes from, one cycle goes from pi halves to 3 pi halves, which is a distance of pi. So if the period is pi, is supposed to be equal to 2 pi over b, we could again do some manipulation here, isolate b, and we would get a b value of 2, which makes sense because 2 pi divided by 2 would leave us with pi. So last, put it all together. I'm not going to put a 1 out in front because, again, multiplying by 1 doesn't change the value. So sine of 2, and then another set of parentheses to represent my horizontal shift, left pi fourths units, minus 2 for my midline there. And if I were to check this with Desmos, my graph would look remarkably similar to this graph in example 4. So there are some practice questions here. There is a Desmos project waiting for you. And there is a challenge question here in number 5, because for all of these, you could think about it as a transformation of cosine as well as a transformation of sine. All you have to do is think about a different starting point. So thanks for tuning in and take care.